Today we're going to begin exploring different types of chemical reactions and the patterns that will allow us to make predictions about what will happen when two reactants get together. We'll look at two patterns today. The first one's called synthesis reactions and the second one's called decomposition. They're actually fairly easy, and you should find it quite possible to make good predictions after we're done talking about this today. In a synthesis reaction, what's happening is two or more substances combine to form a third substance. The generic equation for this, sort of a general description, is we have a first substance we'll call A, and a second substance that we'll call B, and when they combine we get a more complex substance, AB. Quite often A is an element and B is an element and AB is a compound, but an element and a compound or two compounds could also be synthesized. These are easy to spot because there's only one product, and so if you see a reaction and you see only one product, you know this is a synthesis reaction. Here's an example of a synthesis reaction. These students are burning some magnesium. You can see a really bright flame once it ignites, and they're producing magnesium oxide, which is nothing like magnesium, or oxygen for that matter. If the reactants are a metal and a nonmetal, then it's easy to predict the products because the product is going to be ionic, and then you can just use charge swap to predict what the formula is going to be. If the products are both nonmetals, what product exactly you have will be a little bit unclear because it'll be a molecular compound. It'll be covalently bonded. Even though it's slightly harder to predict the products, we can get a little help from bonding preferences. For example, if carbon and chlorine are doing a synthesis reaction, we know some things about how they prefer to bond. Carbon would prefer to make 4 bonds, and chlorine prefers to make 1 bond. So something that makes sense would be put 1 carbon in the center and 4 chlorines on the outside. That's not the only possible compound that carbon and chlorine could make, but it's a good guess. Or hydrogen and oxygen. We know that oxygen prefers to make 2 bonds, and hydrogen prefers to make 1 bond, so what makes sense is bond 2 hydrogens to 1 oxygen, and you end up with water. That's commonly what happens. Again, that's not the only possible product, but it's a good guess. Or hydrogen and nitrogen. We know that nitrogen is a 3-bonder because it's in column 5. Hydrogen makes 1 bond, and so ammonia, which is NH3, is probably a pretty good combination, most likely to happen. All right, so let's predict some products here. I'm going to give you a chance to work this one out. Stop the video, try and predict what the product's going to be for this synthesis reaction, and then I'll give you the answer in a bit. Well, sodium is a metal, and iodine is a nonmetal, so that means this is going to be an ionic compound. To be able to predict the product, we just have to do charge swap. Sodium's in column 1, which makes it 1 plus. Iodine's in column 7, those are always 1 minus. So charge swap, well, we have equal and opposite charges, so the formula is just NaI. Try this one. Well, magnesium is a metal, oxygen is a nonmetal. So again, we're going to make an ionic compound, and charge swap helps us get the formula right. Magnesium's in column 2, those are 2 plus. Oxygen is in column 6, and those are 2 minus. So again, we have equal and opposite charges, and the formula is just MgO. Now here's a common mistake that students make. Looking at the left-hand side, you see oxygen has a subscript of 2. Lots of people want to automatically just say MgO2 when they put that together, but that's not right. Magnesium and oxygen don't combine to make that compound. They combine to make that compound. So be careful. Watch that. A decomposition reaction is almost the opposite. In fact, it is exactly the opposite of a synthesis reaction. This is a reaction in which one substance separates into 2 or sometimes more substances. The generic equation looks just the opposite of what a synthesis was. Here's a complex substance, a compound, and it decomposes to give 2 simpler substances. Quite often those are elements, but they wouldn't have to be. These are easy to spot too because there's only one reactant. So if you ever see a reaction where there's one thing on the left-hand side of the arrow, a single compound, then you know you have a decomposition reaction. Here's a decomposition reaction in which water is being decomposed into its elements, hydrogen and oxygen. And I think you've probably done this one before. These are often pretty easy to predict as well. In many cases, the products will just be the elements that the compound is made of. So in this example, MgO will decompose into magnesium and oxygen. Don't forget the diatomic elements. Oxygen is one of those 7 diatomics, and so we never write it just O. When it's by itself, it's always in pairs. Here's another one, sodium chloride, NaCl. It's made of 2 elements, sodium and chlorine. And again, we have a diatomic. Chlorine is one of the 7 diatomics. Now, these reactions are not balanced, and so we'd have to clean that up with coefficients. I believe a 2 in front of MgO and a 2 in front of Mg would do it. 2 in front of sodium chloride and 2 in front of sodium would balance those equations. Okay, you do this one. Aluminum chloride, AlCl3, is decomposing. Decompose it into its elements, and why don't you balance the equation when you're done? Okay, aluminum chloride is made of 2 elements, aluminum and chlorine. Chlorine, as we saw in the last example, is diatomic. Now, to balance, I have 3 chlorines on the left, and I have 2 chlorines on the right. The least common multiple of 3 and 2 is 6, so I think I'll make myself 6 chlorines on each side by putting a 2 in front of the AlCl3 and a 3 in front of the Cl2. That unbalances my aluminum, but I can rebalance it by putting a 2 in front of aluminum. Try this one. Mercury and oxygen are my 2 elements, and so I'm going to decompose it into Hg, and again, O2 is diatomic. To balance, a 2 in front of HgO, and then I balance the mercury with the 2. Well, those are our simplest type of reactions. In the next video, you're going to learn about 3 reactions that are slightly more complicated, but the patterns are still pretty clear, and none of these is really that difficult.